Have you ever wondered about the importance of suspensions in various industries? Today, let's journey into the fascinating world of suspensions, a ubiquitous concept that's an integral part of industries like pharmaceuticals, food, and cosmetics. In the simplest terms, a suspension is a heterogeneous mixture where solid particles are dispersed throughout a liquid medium. But did you know there are two main types of suspensions? Yes, we have flocculated and deflocculated systems, each with its unique characteristics and applications. As we delve deeper into this topic, we'll unravel the science behind these suspensions, understand how they're formulated, and explore the various elements that go into their making, including suspending agents, wetting agents, dispersants, deflocculating and flocculating agents, structured vehicles, preservatives, color, flavor, and much more. So buckle up for this enlightening exploration. Stay tuned as we embark on an enlightening exploration of these intriguing systems. Now let's delve into the fascinating world of flocculated and deflocculated systems. In the realm of suspensions, two contrasting systems stand out: the flocculated and deflocculated. Each of these systems has its unique properties, characteristics, and applications, making them indispensable in various industries. Starting with the flocculated system, it's a fascinating network of particles loosely bound together. These particles, when mixed in a liquid, form clumps or flocks, which are easy to redisperse upon shaking. One of the most striking features of a flocculated system is its ability to settle slowly. And when it does, it forms a fluffy, loosely packed sediment that is easily redispersed. This makes it the go-to choice in industries such as food and beverages, pharmaceuticals, and wastewater treatment, where easy dispersion and resuspension are key. On the other hand, we have the deflocculated system. Here, the particles are dispersed uniformly and resist coming together to form flocks. These systems are characterized by hard, closely packed sediments that are difficult to redisperse. This is due to the strong repulsive forces between particles, which prevent them from aggregating. The advantage? They provide a uniform and stable suspension, essential in applications where consistency and stability are paramount, such as in paints and coatings, ceramics, and certain pharmaceutical formulations. However, it's not all smooth sailing. Deflocculated systems can lead to a phenomenon known as caking, where the sediment is so tightly packed that it becomes almost impossible to redisperse. This is why, in practice, controlled flocculation is often preferred, striking a balance between the ease of dispersion of a flocculated system and the uniformity of a deflocculated system. So, in essence, whether it's the loosely bound flocks of a flocculated system or the uniform dispersion of a deflocculated system, both play a crucial role in shaping the world around us, from the medicines we take to the paint on our walls. With a clear understanding of these systems, we can now explore the intriguing world of Stokes Law. Ever heard of Stokes Law and wondered what it entails? Well, let's dive right into it. Stokes Law is a fascinating scientific principle that plays a crucial role in understanding the behavior of particles in a suspension. Imagine a tiny particle suspended in a liquid. According to Stokes' law, the speed at which this particle settles, or its settling velocity, is proportional to the square of its radius. What does this mean? It means that the larger the particle, the faster it settles. Now let's put this into context. In a suspension, we have solid particles dispersed in a liquid. If these particles are large, according to Stokes' law, they'll settle quickly, and if they're small, they'll settle slowly. This settling behavior is a fundamental characteristic of a suspension, and it's crucial in the formulation and development of suspensions, but there's more to Stokes' law. It also tells us that the settling velocity of a particle is inversely proportional to the viscosity of the liquid. In simpler terms, the thicker the liquid, the slower the particle settles. So if you've ever wondered why particles in a thick syrup settle slower than in a watery solution, Stokes' law is the answer. Moreover, Stokes' law is also influenced by the density difference between the solid particles and the liquid. The greater the density difference, the faster the particles settle. So if you have a dense particle in a less dense liquid, it's going to settle quickly. Understanding Stokes' law is pivotal in the pharmaceutical industry. It helps in predicting the behavior of particles in a suspension, guiding the choice of excipients, and thus influencing the formulation and development of suspensions. It is a vital tool in ensuring the stability and effectiveness of a pharmaceutical suspension. So, there you have it. Stokes' law in a nutshell. It's the science behind the settling behavior of particles in a suspension, and it's a crucial player in the world of pharmaceutical suspensions. Now that we've mastered Stokes' Law, it's time to move on to the formulation and development of suspensions. Ever wondered how suspensions are formulated and developed? Let's delve into this fascinating process. The first step is to select the right excipients, which are substances used alongside the active pharmaceutical ingredient. These excipients play a crucial role in the formulation of suspensions and include suspending agents, wetting agents, dispersants, deflocculating agents, and flocculating agents. Suspending agents are essential for providing the necessary viscosity to the suspension, ensuring that the particles remain evenly distributed throughout the liquid. Examples of suspending agents include cellulose derivatives and gums. On the other hand, wetting agents reduce the surface tension between the particles and the liquid medium, promoting dispersion. They ensure that the particles are thoroughly wetted, which aids in the suspension of the particles. Next, we have dispersants and deflocculating agents. Dispersants assist in the dispersion of particles, preventing any clumping or aggregation. Deflocculating agents, in contrast, prevent the particles from forming large, heavy clumps that would settle rapidly. They do this by providing a repulsive force between particles, preventing them from coming together. Flocculating agents, however, promote the formation of loose, fluffy clusters of particles known as flocks. These flocks are large enough to settle quickly but are easily redispersed upon shaking. This is beneficial as it prevents the formation of a hard, compact sediment that may not be easily redispersed. Finally, the formulation process involves blending all these components together to form a uniform suspension. This involves careful consideration of the order in which the ingredients are added, the mixing technique and speed, and the temperature conditions. The development of suspensions also involves rigorous testing to ensure the final product meets the necessary quality standards. This includes testing for particle size and distribution, viscosity, sedimentation rate, and redispersibility. Armed with this knowledge, we can now delve into the final topic, structured vehicle. What exactly is a structured vehicle, and how does it contribute to the properties of a suspension, you might ask? Well, in the world of suspensions, a structured vehicle is not a car or truck, but rather a cleverly designed system that keeps the suspended particles from settling. It's the hidden hero that ensures your medicine maintains its consistency and effectiveness. The structured vehicle is essentially a web of interconnected particles or chains that form a network throughout the suspension. This network provides resistance to the settling of suspended particles, improving the stability and uniformity of the suspension. So you can think of it as the scaffolding that keeps the whole suspension intact. Now, beyond the structured vehicle, there are additional elements that enhance the properties and aesthetic appeal of suspensions. These include preservatives, color, and flavor. Preservatives are added to suspensions to prevent microbial growth, ensuring the suspension remains safe for consumption over a period of time. Color, on the other hand, is all about making the suspension visually appealing. It might seem superficial, but the color of a suspension can play a significant role in patient compliance, especially in the case of pediatric patients. A brightly colored, visually appealing suspension is more likely to be consumed without fuss by a child than a dull, colorless one. And then we have flavor. As with color, flavor is a crucial factor in patient compliance. Let's face it, nobody wants to consume a medicine that tastes like the bitter end of a bad day. Flavoring agents are added to suspensions to mask the unpleasant taste of the medicinal ingredients, making the medicine palatable and easier to consume. In a nutshell, a structured vehicle and these additional elements work together to create a suspension that is stable, safe, visually appealing, and palatable. They are the unsung heroes that make our medicines not just effective, but also consumable. Now, equipped with the knowledge of suspensions, we can appreciate their significance in our daily lives. So, we've covered quite a bit about suspensions today, haven't we? We ventured into the intricacies of flocculated and deflocculated systems, unraveled how they differ, and how each system has its unique place in the realm of pharmaceuticals. We dived into Stokes' Law, a fundamental principle that helps us understand how particles settle in a suspension, influencing its stability and efficacy. Our journey took us further into the formulation and development of suspensions, where we discovered the art and science of creating the perfect balance of ingredients, a testament to the marvels of pharmaceutical engineering. Lastly, we discussed structured vehicles and the role of additional elements like suspending agents, wetting agents, dispersants, and more. These elements aren't just additives, they are the unsung heroes that ensure the suspension's consistency, effectiveness, and patient acceptability. So what's next? More exploration, more knowledge. Subscribe for more because you won't find me later. Stay curious, stay informed, and keep exploring the world around you.